Okay. I've actually switched roles within Microsoft. I'm now the Chief Architect for Standards and Consortia for Microsoft Azure IoT. As part of that, I represent Microsoft in various different standards organizations and consortia, including obviously the OPC Foundation, the Platform Industry 4.0, and the IIC in the US. Today, again, I'm going to focus really on giving practical advice on how to use OPC UA in the cloud. So vendor lock-in is something that you should be familiar with. I've talked about it many times before, but just as a summary, vendor lock-in means that you're locked into a specific vendor because they force you to use a closed source SDK or a proprietary interface, proprietary communication, or in fact, what happens a lot, proprietary data model. Also, sometimes it can be more subtle. Sometimes they talk about running particular software on a specific set of hardware or data center. That's also lock-in. So whenever you see things like that being communicated to you, be careful. You need to evaluate if the solution is worth it for you, or if you would prefer a solution where you can leave and use a different solution at any time. So in general, obviously we've been using OPC UA for a long time. Really, we've started integrating OPC UA in 2014. We launched our first OPC UA based product in 2016, but we've really been part of the OPC Foundation since 1996, since the beginning, really. And the reason why we think OPC UA is so suitable for cloud solutions is because it gives you interoperability. It gives you, data modeling capabilities, and it also gives you built-in best-in-class security. So OPC UA doesn't actually define the data model itself. It only defines how data should be modeled. The data models actually come from the industry, from the ecosystem. Obviously, the VDMA is doing a lot of data models right now for the different machine types, but it's not exclusive to the VDMA. There's many other organizations that are building OPC UA information models that then allow you to build standardized software based on those data models, also in the cloud. So one of the ones I'm currently involved with is I'm working on a carbon capture and storage project in Norway called Northern Lights, and one of the most suitable data models for Northern Lights is in fact MDIS, which is a data model for the so-called master control station, which is the thing that sits on the ocean floor in the carbon capture and storage project. In fact, we're pumping CO2 through that master control station underground, secured, stored permanently underground, in the rock formations on the bottom of the ocean. And as you can see, many companies are involved in the MDIS standard, and with a multi-company project like Northern Lights, it's super important to actually base the solution on open standards, so you have that built-in interoperability. Okay, I put this slide in because I get a lot of questions regarding the different consortia and the different organizations that are kind of doing Industry 4.0 solutions and how they all fit together. So I put this together mainly as an overview. Obviously, there are a number of input organizations that contribute to the platform Industry 4.0, and you see them there: the Bitkom, ZVI, the VDMA that I mentioned before that are building the companion specs, obviously the OPC Foundation, and also the Automation ML Consortium, and they all give input to the platform Industry 4.0. And the platform Industry 4.0 then makes recommendations, a reference architecture, and a small set of standards that they recommend for Industry 4.0 solutions. And then there are the user organizations that are actually using the recommendations from the platform, and there's many of them. In fact, you get a lot more of these as Industry 4.0 solutions become more popular. Here are just a few that are, the most popular, or the ones that are currently the busiest, let's say. Next week at Acima Pulse, we're going to hear more about Namur and how they're using OPC UA. But there's many other ones out there that can be used. And of course, it's important to kind of know, is it a user organization? Is it a standards organization? I didn't even mention the standards organizations like the IEC or OASIS here, but obviously it's very confusing if you're not involved with these organizations on a daily basis. So I thought I'd put this together. So regarding the reference architecture that the Platform Industry 4.0 put together, it's called RAMI. And as you can see, it's kind of a three-dimensional architecture, and for the production and maintenance use, OPC UA is set also on the information model and the communication layer. So, towards the cloud, towards the connected world, that is OPC UA PubSub. And, OPC UA PubSub is what I'm going to be talking about mainly going in the next few minutes. So in terms of the asset administration shell, which is one of the things that the Platform Industry 4.0 has defined together with the ZVI, it's mainly a data sharing service. So people get very confused when they hear asset admin shell. What is it? It's mainly a data sharing service. It also defines a file format, like a container format. It's actually using the OpenOffice XML format. And it's currently being turned into an IEC standard. And there's a mapping to OPC UA, but most importantly, when you're creating an asset admin shell around an OPC UA enabled asset, it's important to keep the OPC UA information model intact, so you can use that OPC UA information model at the receiving end, right? And to do that, you need to create an asset admin shell from an OPC UA node set file, which is the file format obviously for OPC UA information models. And how to do that, I put together a demo, open source. It's on GitHub. I've linked it down here. So this is also an important step towards leveraging the asset admin shell with OPC UA. So now let's switch gears and talk a little bit about the practical steps and what you can do to avoid vendor lock-in, and specifically, what questions should you ask yourself when you're starting an industrial IoT project. So here are the 5 questions, and I'll go into each one of them in detail now. One of the things you should know is, the transport protocol, which is what most people tend to spend time on, is largely irrelevant, right? I mean, OPC UA is transport protocol independent, as you probably know, and MQTT is one of them, which can be used, and there's a defined mapping specified in the OPC specification, but you can use any protocol you want, really. And what's more important than the protocol to use, it's the data format and the data model. So let's go straight on it into it. And here's the first question. So what data model should you pick, right? And people a few years ago said, yeah, data is the new oil and data is so important. I tend to disagree. I think it's the data model that is actually the most important choice when you're doing an industrial IoT project. And really, you want to pick a data model that's based on an IEC standard, like OPC UA, because that gives you vendor independence. And, when a certain solution asks you to model your asset again, be careful. Alarm bells should be ringing, because it means that the data model that that particular solution uses is proprietary, right? Much better is, we can't always build all software using open standards. I get that, right? But at least you should be able to import a data model based on an open standard and then also read the data out again in an open standard, even if the internal storage of that data and data model is proprietary. That's fine. However, standard data in, standard data out, and that's what you should be looking for. And also, I mean, people tend to confuse the word open with standard. I mean, lots of people think that once they open source something, it becomes magically a standard. It doesn't work that way, right? So a standard is released by a standards organization. So if it doesn't have an IEC number or a number from OASIS, it's not a standard, right? It's still proprietary, even though it's open source, right? So be careful there. There's a lot of confusion that some people are generating right now with that. So the next question you should ask yourself is, where do you want to do your data normalization? So guess what? When you're doing cloud analytics, all your data should be in the same format, right? Otherwise, cloud analytics becomes super complicated, right? So where do you do that data conversion? And the best place to do that is as early as possible in your telemetry pipeline, which means on premises, right? On the edge, that's where your data conversion should happen. And I mean, it's also, a lot simpler to convert data from different sources on the edge, because chances are on that particular edge installation on premises in your plant or in your factory, you have the subject matter experts that actually can explain to you what data the data represents, or what formats in and what assets sit behind it, or what database or whatever it may be. They're usually on-prem. They're right there in the factory, and that's where you have the best success of making sense of the data. The other thing that you should ask yourself is, what telemetry format would you pick, right? Because ever so often you get these industrial IT experts, on YouTube or whatnot, and they come up with this new hip and trendy, super efficient, if we've tried it on a Raspberry Pi and it works great, data format. Well, it doesn't matter, right? Because if it's not in an open format that is also readily available from cloud services, you'll have to convert the data in the cloud again, right? And another thing that happens a lot is that you convert your data on the edge in that super efficient format, you send it to the cloud, and then you need to convert it back to something that the cloud services or the cloud databases actually understand, right? And all of this you have to pay for, and it adds zero value, right? So it's much better to convert your data once on the edge into a standard format, and that format should be something that the cloud readily understands. And believe me, actually sending data to the cloud these days is cheap, but the conversion of data, especially if it has to happen in the cloud at scale, can cost you a lot of money very quickly. And again, it's money wasted. So then the next one is, how much scale do you actually need? I mean, a lot of the times this is easier done in a small project where scale doesn't really, make that big of a difference. But as you go into production with a project, it tends to be difficult to scale it out if you haven't thought about what services you're going to use for that scale out from the start. And I mean, really what you want to do is use services that auto scale, right? Where you don't need to worry about, is it, wasting resources right now because you've made the compute too big, or is it actually bursting at the seams, and you're dropping data because you can't process it fast enough. So these auto scale services are really handy. That it only really scales as you need it. And you really should think about some of the use cases that you have up front as well, because again, once you build your scalable architecture, if you have your use case in mind, it becomes a lot easier. So then the last question is, do you need to integrate third-party systems? And, chances are, yes, you do, right? I mean, not all the data is in one place in your factory, right? It's usually spread in various different data silos, right? And each one of them need to be integrated. And, when it comes to historian integration, you want to bulk upload that data. You don't want to, stream the data. So you need different upload mechanisms to your cloud solution, right? And you need to build that in upfront. And again, ERP systems are usually also very proprietary, and it's important to plan the integration of the ERP systems upfront so there aren't any surprises halfway through the project, right? And I'm speaking from experience here. So again, it's important to plan ahead. Choose services that can read data from multiple different sources and process it, right? And it's important to keep that scale in mind as well. So now very quickly about this whole OPC UA versus MQTT, which is a hot topic on LinkedIn and everywhere else. Like I mentioned, OPC UA is protocol independent. MQTT is first and foremost a transport protocol, right? So, you really need to get off the idea that, OPC UA competes with MQTT. It doesn't, right? It leverages it and has been doing that for many, many years, right? It's in part 14 of the spec. At Microsoft, we've been using it since 2015. We found it super efficient. And, it also, together with the OPC UA PubSub JSON encoding, requires no conversion of the data in the cloud. You can feed that JSON PubSub data straight into cloud databases or analytics software, which is super efficient and has great benefits, as I've already highlighted. And of course, it's an IEC standard now, so it doesn't lock you in. Okay, so the Microsoft Industrial IT Stack, not much has changed here. Some of the servers have been updated, but in general, if you haven't seen this before, obviously the Industrial IT Stack is split into layers. At the bottom, you have your infrastructure, your VMs, your networking, your user management, all of that. On top of that, you have your managed services, which are, again, vertical independent. They are generally applicable to many different use cases. And you have your IoT Edge, your Hub, your Data Explorer, and Data Lake, and all of those things in there. And again, Microsoft carries the beeper. You don't need to worry about keeping that service up and running. Microsoft does that for you, right? And then on top of that, we built our industrial IoT platform, open source, based on OPC UA. It's all on GitHub, right? And that gives you that interoperability and avoids lock-in. And some folks prefer to actually have a shrink-wrapped solution. They just need to create an account, they get a login and use the solution the way it is, and that's called software as a service. That sits on top of that, right? So examples of that are time series insights with its own dashboard, IoT Central, Power BI, which is a no-code dashboarding solution. So all of that is available from Microsoft. And of course, as we have a huge partner ecosystem, they are also leveraging those layers. They pick one and leverage it. They can leverage multiple layers at once, of course, and they are the ones, they're the ones that build the specific services for the industrial use cases and managed applications as well. So the SAP Cloud or PTC ThingWorks, Siemens MindSphere, they are great examples of some of the partners that we have running on this. Okay, so what does this industrial IoT pipeline that I mentioned actually look like? Well, this is it. So you have your assets on the left, on-prem. Sometimes these are aggregating assets, so there's multiple physical machines connected to a single aggregating asset, like an OPC UA aggregation server. or it's just a plain OPC server, right? That can happen as well quite a lot these days. More and more people build OPC UA directly into the machines, which is great, right? And then obviously you have some sort of gateway running on-prem that are sending data then to the cloud gateway. Then again, because we're using PubSub, you can connect your time series database directly to their cloud gateway, no data conversion required. And then you can have your analytics software run queries against your time series database, or if you want to create that digital feedback loop, you have you know, serverless compute services like Azure Functions that can also run queries directly on a time series database, or in fact on the analytics software, and then via IoT Hub methods, you know, which again translated back into OPC UA method calls, you can have your digital feedback loop back into the asset. And unfortunately, almost everybody else, not everybody else, but almost everybody else still uses a completely proprietary telemetry pipeline, right? And that's the big differentiator that, you know, Microsoft Azure Industrial IoT has. We use OPC UA to the best of its capabilities, right? And, you know, again, you know, as OPC UA PubSub is extended with new features, we built them in. There's a bit of a but here. Data is meaningless without context. So where does the context come from? Obviously, the context comes from the OPC UA information model. And that's what the missing piece is. And that's why we created the OPC UA Cloud Library Working Group to allow data model upload to the cloud that can then be used through queries, which are also going to be standardized through OPC UA for that telemetry pipeline. And there's another session today specifically on the cloud library. It's been running as a collaboration with the Clean Energy and Smart Manufacturing Innovation Institute in the US. So we're going to hear about that in detail later on. So this may come as a shock to you, but not every machine or PLC out there supports OPC UA out of the box yet, right? So you're going to have to use industrial connectivity software, right? The good news is that Microsoft has been doing, you know, partnerships with connectivity software providers for a long, long time, and you know the list of modules that are available in the Azure marketplace keeps growing. Here's a snapshot, and we're very proud to have the largest ecosystem of partners for industrial IoT software, all of which are providing an OPC UA interface to us. And again, you can check out the marketplace for a list. So very quickly, what does you know, a simple connectivity telemetry pipeline look like on Azure? Well, here it is. Like I mentioned, you know, if your asset supports OPC UA out of the box, you can connect OPC Publisher, which is open source on GitHub, you know, straight away. Otherwise, you need that connectivity adapter, connectivity software from the Azure Marketplace. OPC Publisher runs inside of Azure IoT Edge as a Docker container, and then Azure IoT Edge gives you store and forward capabilities. So if you have a, you know, unreliable internet connection, that's taken care of. And then you just have, you just have a IoT hub as a cloud gateway in the cloud. So that's connectivity. So then how does condition monitoring look in addition to connectivity? Obviously, condition monitoring leverages connectivity. Well, the only thing you really need on top of that is a OPC UA-enabled cloud dashboard, and we're going to release such a cloud dashboard open source at Acima Pulse next week. And then in terms of predictive maintenance, well, not a lot needs to change either. All you really need is you know, a time series database with analytics capabilities, and Azure Data Explorer does that for you. And I've blogged about this on LinkedIn. Sorry, I blogged about this on LinkedIn a while ago. So this is definitely something that is easily achieved, and you can just read the blog post there. So what does the entire architecture look like, including what is needed for digital feedback loop? Well, here it is. Obviously, it's a bit more complicated, but it's not rocket science. You can connect this up in a few days. These OPC services are all open source on GitHub. They run on Kubernetes. They're Docker containers, and Synapse is our analytics PaaS service. And of course, if you want long-term storage, which of course is a good idea, to store your telemetry data long-term, you have Azure Data Lake available as well. And then for the apps, you can of course use your own dashboards or Power BI or a combination of both. So then, in summary, you probably know this kind of step-by-step diagram. The main message here is don't get locked into a proprietary vendor solution. Use open standards, and Microsoft supplies that open standard-based platform. And we can help you at every step and make you successful in your industrial IoT project. And with that, I am at the end of my presentation. Thank you very much.